All right, so getting started here, and that information's on the board. Again, it's on your note sheet from Friday, just reviewing sine, cosine, tangent. You are going to need for your assignment, you will need a calculator for today. So we're starting out on Friday. We found missing side lengths of right triangles that had one of the three special angles, 30 degrees, 45 degrees, 60 degrees. So we were finding the exact values. Today, we're starting out, you're still going to be finding the side length of a right triangle, but you will not have one of those special angles. So we can use a calculator in that case to find that side length. So for example 1, we're using a trig function to find the value of x in the triangle given, round to the nearest tenth if necessary. So based on where the angle 24 degrees is, I would recommend labeling the x and the 11 in terms of opposite, adjacent, hypotenuse to figure out what trig function you need. So what would x be? What side is that? The hypotenuse. And the 11 is the side opposite the angle of 24 degrees. So what trig function uses the hypotenuse and the opposite?
It looks like you have
Sine, opposite over hypotenuse. So setting this up, we have sine of 24 degrees is equal to the opposite over the hypotenuse. So 11 over x. And then we solve this equation for x. And like I said, you will need your calculator today for the sine of 24 degrees. So before I calculate anything though, I usually do all the calculating at the end. What would I do to solve for x? I'm hearing a lot. Somebody raise your hand. What would you do first? Abby? Yes. X is currently in the denominator. Get it out of the denominator. You can do that by multiplying both sides by x. So I'm not going to calculate sine of 24 right away because then I would be approximating it. I'm going to do all of that at the very end. So I have x times sine of 24 degrees is equal to 11. And then to solve for x, I can divide both sides by the sine of 24 degrees. So then I would calculate 11 divided by sine of 24 degrees on the calculator. So depending on what calculator you have, you'll need to figure out where your sine, cosine, and tangent functions are on there, which you've probably used in geometry. So on here, they're kind of in the same row as that division key. You have a sine, cosine, and tangent key on this calculator. So I just type in 11 divided by sine of, and then sine always comes up, cosine and tangent do this too. They always come up with a parenthesis, then you're entering what input is being put into the sine or cosine or tangent function. So sine of 24, close parentheses, enter. And then you are rounding to the nearest tenth if necessary. So rounding this to the nearest tenth, we would leave it as 27.0, or just 27. All right, are there questions on example 1? Yes, during work time, I'll help you out. So if you have questions on using your calculator, or if you typed this in and you're not getting 27, it is possible your calculator is not in degree mode and it's in, say, radian mode. So in that case, you would get a different answer. I can help you out with that when you have time to work. Just make sure you let me know. I'm just going to put this out there. This is the hour I'm recording, so if you want to hear how noisy you all are, you can watch this back.
Hi, guys!
It's not something to be proud of. It's pretty rude to me and to those that are trying to pay attention. So, in this next part, we are now going to be using trig functions to find angle measures of a right triangle. So, it says here, when you're solving equations like 3x equals negative 27, you use the inverse of multiplication to find x. So the inverse of multiplication would be dividing each side by 3. So we can also find angle measures of right triangles by using the inverse of sine, cosine, or tangent. So I first want to show you what that notation looks like. You may remember it, again, if it came up in geometry. So inverse sine is written this way, so it's still sine of x, but it looks like there's an exponent of negative 1. It is not an exponent, it's just the inverse notation. So this means inverse sine. And then inverse cosine and tangent are written very similarly. So here's the notation for inverse cosine, that again is a negative 1 there. And then inverse tangent, again, written very similarly. But these are the 3 inverse trig functions. And I included off to the side, for a couple of reasons I included this. One, it's important to understand what the inverse trig functions help you find what they represent. So it says here the expression inverse sine, we read that as the inverse sine of x. It's interpreted as the angle whose sine is x. So if you are trying to find an angle measure, inverse sine of x would help you find out, or the answer to that would be the angle whose sine value is whatever x is equal to. And then it does say there also be careful not to confuse this notation with the notation for negative exponents. So we know a negative 1 as an exponent means the reciprocal, but inverse sine is not the same as 1 over sine. The reciprocal of sine we learned on Friday is cosecant of x. So inverse functions and reciprocal functions are not the same. And then it also says there instead that this notation is similar to the notation for an inverse function. So if you remember our inverse function notation where it looked like f to the negative first power of x, but that was read as f inverse of x, or the inverse of f of x, that's what this notation is very similar to. So there is a worked out example here. Say you have sine of a is equal to 0.5. If this was your equation, you could use inverse sine to solve for angle A. And so notice you are not going to divide both sides by sine in this case. Sin alone means nothing. It's always sine of something else. So you can't just divide by sin. That means nothing. So rather than dividing by sine, since that is impossible, you take inverse sine of each side. And inverse sine and sine cancel each other out because they're inverse functions, and you're just left with A, so you're finding the measure of angle A. And then on the right side, you have to calculate what inverse sine of 0.5 is. So at what angle does sine equal 0.5 is what you're finding. On the calculator, you can figure this out. Again, you'd have to find it on your calculator, but on this one, right above the sine, cosine, and tangent piece, you'd have to hit second first. You see the inverse notations for inverse sine, cosine, tangent. So I would hit second sine to get inverse sine, and then type in 0.5 equals, and in this case, the measure of angle A would be 30, and that's in degrees. Okay, any questions on that? We have a couple examples to go through using it, but that's another thing you want to make sure you know where to find it, how to use it on your calculator, and if you're not quite sure at this point, I can help you when there's time to work. So in examples 2 and 3, we are finding the measure of each angle rounding to the nearest tenth. So I see in example 2 where the angle x is. Again, I want to figure out what trig function to use. So figure out what the 15 and 17 are in terms of opposite, adjacent, hypotenuse. So what is the 15? The adjacent, and the 17? So what trig function do we need? Cosine, yes. Cosine is adjacent over hypotenuse. So I would set this up first, that cosine of x is equal to 15 over 17. All right, and then I'm trying to solve for x. So again, I'm not dividing by cosine, because that means nothing. I take inverse cosine of both sides. So inverse cosine of x will equal inverse cosine of 15 over 17. And on the left side, the inverse cosine and cosine cancel out, so you're just left with x because they're inverses. And then in the calculator, we calculate what inverse cosine of 15 over 17 is. So I would type in second cosine for inverse cosine, and then 15 divided by 17, close the parentheses, enter. So rounding to the nearest tenth, this would be about 28.1, and x is measured in degrees. Questions on example 2? All right, example 3 is very similar. Locate where angle x is. Figure out what trig function you need. So in terms of opposite, adjacent, hypotenuse, what is the 18? And the 27? So what trig function is needed? Tangent. Opposite over adjacent. So tangent of x is equal to 27 over 18, opposite over adjacent. And I could show, like I did for example 2, that I'm taking inverse tangent of each side, but I know it's going to cancel out on the left. So I can also write it this way, that x will equal inverse tangent of 27 over 18, and then calculate this with the calculator. However you want to show what work you're doing is up to you. I just need to see how you're getting your answer that will help you in terms of partial credit. So second tangent for inverse tangent, 27 divided by 18. And rounding to the nearest tenth, that's about 56.3 degrees. Any questions on examples 2 or 3? Okay. For the last couple of examples, this is now applying or using trig functions with given situations to answer questions. So I know the figure at the top is copied pretty dark. I just want to explain what this is saying in terms of angles of elevation and depression. So in this figure, it might be hard to see. This is a swimmer in the lower right here, assumed to be in an ocean or a lake, something like that. And then there's a lifeguard here. So could be a pond. So the angle formed by the line of sight from the swimmer, so that would be from the swimmer to the lifeguard and a line parallel to the horizon from the swimmer, that angle formed between those two lines would be an angle of elevation, because from the horizon, the angle, your angle is going up there, so it's an angle of elevation, versus if you are at the lifeguard's point of view, their horizon is up here, or their line parallel to the horizon, and then their line of sight to the swimmer is now going down. So that would be an angle of depression, or it's sometimes called an angle of descent. So if you see angle of elevation, angle of depression in a problem, you just want to be able, know that when you're setting up a triangle, that you're setting up where the angle is correctly. That's the big part of it. So, for example, we have this moving truck, and you can see on the end of the moving truck, there's a ramp. You can kind of picture here that the ramp, if we draw it in the vertical line, and then with the ground and the ramp, that creates a right triangle. So we have a ramp for unloading. A moving truck has an angle of elevation of 32 degrees. If the top of the ramp is 4 feet above the ground, estimate the length of the ramp. So I'm just going to draw this right triangle a little larger that is created by this ramp. So first of all, the angle of elevation of 32 degrees, so that would be the angle that the ramp is creating with the ground. So that angle is 32 degrees. And then it says if the top of the ramp is 4 feet above the ground, estimate the length of the ramp. So which side in relation to the 32 degrees should be labeled as 4 feet?
Opposite.
The opposite side. Right, that's 4 feet. And then which side are we trying to find in relation to the 32 degrees? The hypotenuse, the length of the ramp. All right, so which trig function is going to help us find x? Sine. So sine of 32 degrees is equal to the opposite over the hypotenuse, so 4 over x. And then we solve for x, and we solved a similar equation like this in example 1. So we multiply by x first. So x times sine of 32 degrees is equal to 4. And then divide by sine of 32 degrees. About 7.5. Yep, and it doesn't say, but all in all, you can round to the nearest tenth unless it tells you otherwise. So it is about 7.5. And what units would be on x? Feet. So the ramp is about 7.5 feet long, based on the angle of elevation and the vertical length of that triangle. Okay, so we have one more, but for these, you just have to be able to read through. It's very helpful to draw a diagram if one isn't given to you already. So example 5, no diagram is given. We have the hill of a roller coaster has an angle of descent, which is an angle of depression of 60 degrees. Its vertical drop is 195 feet. Estimate the length of the hill. So for the hill of a roller coaster, so picture you're on a roller coaster and it's where it's going down, that hill we're talking about. So trying to draw that hill as linear as I can here. Okay, and if you want to, you can kind of picture maybe the roller coaster cars at the top. I don't know. But we have the hill has an angle of descent or an angle of depression of 60 degrees. So angle of depression, that means if from the top we were to make a line that would be parallel with the horizon, this angle formed by that horizon and the actual hill is 60 degrees. So I'm actually going to draw that line in as part of the triangle, and then I could draw in the vertical of that triangle as well. So you can see how a right triangle could be created to figure out the length of that hill. So then it says its vertical drop is 195 feet. So in relation to the 60 degrees, where would the 195 go? Opposite. And we're estimating the length of the hill, which in relation to the 60 is what? The hypotenuse. All right, so we need sine again for this one, opposite over hypotenuse. So sine of 60 degrees is equal to 195 over x. I'm going to shorten up the work I show for this one. It's very similar to the previous example. We know we're going to multiply both sides by x, divide both sides by sine of 60. So x is going to equal 195 divided by sine of 60. Point 2. Okay, 0.2. And that's measured in what unit? Feet. So the hill is approximately 225.2 feet.
Question.